Hey guys, Mr. Betts here. I want to take a look at another example where we are relating limits to definite integrals. This time, what I'm calling a level 2 example is going to be the reverse of what we did with the level 1 examples. So if you remember in the level 1 examples, we had a definite integral that we wanted to write as a limit. And we have a little bit of flexibility when we're doing that, so it's generally a little bit easier. Now we have a limit that we want to rewrite as a definite integral. So essentially what we're looking for in this problem is a definite integral in this form, where we need to figure out what a and b are, we need to figure out what f is, so that we can say this limit is equal to some area problem written as a definite integral. So I'm going to kind of start with this right here in a general form and think about how we can work backwards towards that. So a few things here. This is going to be equal to the limit as n approaches infinity. Now this one's using k here for the sum, so I'm going to use k. So it's going to be delta x times the sum from k equals 1 to n. And I'm going to use RAM. Generally, RAM we're going to use more often, so I'm going to write out RAM here and kind of hope it matches up. If it doesn't, I might have to make some adjustments. So RAM is going to be f of a plus I delta x. So remember, we're just plugging this a plus I delta x in for x into the function here. So if we look at what we've got here, this 4 over n looks like it's going to be our delta x. There's a very good chance of that. In fact, we can just say that it's delta x, and we're actually going to be able to change delta x if we want to, and that's just going to change what the integral looks like. But we, regardless of how we do it, as long as we're doing it correctly, we'll have equivalent definite integrals. All right, so the point that I'm making there is we could have more than one definite integral. So definite integrals that look different, but they are all equivalent because they give us the same area. So we're going to say that this is delta x. So that's going to be 4 over n, which means that b minus a over n is equal to that. And so what that tells me is that the width of the entire interval is going to be 4. So we're going to have an integral that's maybe going from 1 to 5, or an integral that's going from 0 to 4, or an integral that's going from 20 to 24. I don't know what those limits are yet, but I do know that the distance between a and b has to be 4. All right, so that's a pretty good starting point there. Also, notice here we have something over n. So this expression right here, if delta x is 4 over n, is going to be 2k times delta x. All right, so I'm going to rewrite this expression here. I'm going to write the delta x here. So this is equal to the limit as n approaches infinity of delta x. Okay, so we've already figured out what delta x here. We're done with that. And then sum from k equals 1 to n of the sine of 6 plus 2k delta x. So what I want to do next is look at this right here and see if I can make that into a form like this right here. It's pretty close. I made a mistake here. That I should be a k. It is pretty close, except we have this 2 here that's kind of getting in the way. So what I'm going to do is I'm going to factor that 2 out. And so what we have in here is the same thing as 2 times 3 plus k delta x. And so that makes me think now, based on what we have, that this a here is going to be 3. So remember, this is the sine function. It's the sine of this. So if we say a is 3, now we've got this part right here done. And we're getting pretty close now. So if a is 3, then a plus k delta x is taken care of here. And so what that means is this part right here is replacing the x in f of x right here. So I'm going to rewrite this again. So delta x sum k equals 1 to n of, so what I'm going to do is I'm going to say f of x equals the sine of 2x. And if we say that, then this whole thing right here is just going to be f of a plus k delta x. So this limit right here is exactly the same as this limit. So essentially what I did is just one piece at a time. I kind of chipped away at it and I said, okay, what does a have to be? What does delta, sorry, should have started with delta x. What does delta x have to be? Then we were able to figure out what a is by getting this part into this form right here. And then based on what we knew then, this right here is the x in our function, which gives us this function here. So after all of that, this is going to equal then the integral. A, remember we said, is going to be 3. The width of the interval has to be 4, so it's going to go from 3 to 7 of the sine of 2x. Don't be afraid to watch this video again if you got lost in there.